How did the Lunar Module influence future space travel? How did the Lunar Module influence future space travel? The Lunar Module, developed in the 1960s as part of NASA's Apollo program, was a game-changer in space exploration. This spacecraft was the first designed specifically for landing on and taking off from the Moon. It represented a major leap in technology during that era. NASA adopted the Lunar Orbit Rendezvous method to reach the Moon. This approach involved sending two spacecraft into lunar orbit, the Command and Service Module and the Lunar Module. The Lunar Module would detach, land on the Moon, and then return to dock with the Command and Service Module for the trip back to Earth. This method allowed for a lighter and more efficient spacecraft design compared to other options that required landing the entire Apollo spacecraft on the lunar surface. Constructed by Grumman in New York, the Lunar Module had two stages. The descent stage was used for landing, while the ascent stage was for returning to lunar orbit. It included advanced systems like the primary guidance, navigation, and control system developed by the Massachusetts Institute of Technology. The engines were designed by Rocketdyne and Bell Aerosystems, which made it possible for astronauts to land safely on the Moon and return, a feat that had never been accomplished before. The success of the Lunar Module during the Apollo missions, especially Apollo 11 in 1969, achieved President John F. Kennedy's goal of a crewed lunar landing. It also showcased new capabilities in spacecraft design, navigation, and human spaceflight operations. The design principles of the Lunar Module influenced future spacecraft by demonstrating that modular, mission-specific vehicles could be more effective than single, all-purpose spacecraft. The techniques used for rendezvous and docking in lunar orbit became standard for future missions, including those involving space stations and interplanetary travel. The development of the Lunar Module also pushed forward technologies in lightweight materials, propulsion, and life support systems. These advancements contributed to the broader field of aerospace engineering and informed the design of subsequent spacecraft, including those used in the Space Shuttle program and modern lunar landers. From the perspective of the 1960s, the Lunar Module symbolized American ingenuity and the spirit of exploration. It embodied the daring and optimism of that decade, inspiring generations with the proof that humans could leave Earth, walk on another world, and return safely. The Lunar Module influenced future space travel by pioneering the lunar orbit rendezvous technique, advancing spacecraft technology, and setting operational standards for landing and returning from extraterrestrial surfaces. Its legacy continues to shape how missions are planned and executed beyond Earth.